Introduction to Solar Charge Controller. In this session, we're going to be talk about what do you mean by the solar charge controller and what is the basic role of the solar charge controller actually whenever we are talking regarding the solar charge controller functioning in the solar home systems over here. So basically the solar charge controller, as the name suggests itself, it is a charging controller for the battery actually. So whatever the battery we are using in the solar home systems, so how much amount of the voltage and the current it is should be go to the battery over here. So that has to be controlled by the solar charge controller actually. So solar charge controller have a intelligent function. It says that what is the corresponding battery will have a status of the charging over here actually. If a battery is 100% charged, it will cut the supply of a battery. It's the cut the supply of the voltage and the current or whatever the supply is coming from the solar panel, so that this battery will not going the mode of the overcharging over here actually. If a battery is continuously goes on the mode of the overcharging, then whatever the electrolyte has been present inside the battery, whether it is a lead acid battery or any other battery, we are going to use it over here. So that is why the safety it has been taken by the solar charge controller while the battery is getting charged. In some cases, if a battery will have a depth of discharge of the 50%, so that time the solar charge controller sense that the battery will have a depth of discharge up to the 50%, and again it will connect the solar panel supply towards the battery for the charging purposes over here. So ultimately, whenever we say actually any kind of the voltage and the current that we are getting from the solar module, it is continuously varying in the terms actually. The voltage and the current is simultaneously increasing or the decreasing over here actually. It happens because the irradiation level which is falling over the solar panel. So to convert the variable form of the DC voltage to the standard or the stable form of the DC voltage, that is also the main function of the solar charge controller. So that is why the functionality of the solar charge controller is very important whenever we just design any kind of the solar home systems. So the first case we're going to see the solar home system which is running the DC loads over here actually. DC load in a sense whichever home appliances that are running on the direct current mode actually. So they don't require any kind of the alternating sinusoidal waveform to run the corresponding home appliances. So in that cases, whatever the power has been generated by the solar panel due to the absorption of the photon from the sun's radiation, it has been given to the solar charge controller. So some amount of the voltage and the current has been fed to the solar charge controller. It will going to display what amount of the voltage and the current is going to fed to this corresponding charge controller, and according to that it will going to charge the battery over here. It will sense the position of a battery, what is the status of charging of a battery, whether it is a 90% has been charged, whether it is a 50% has been charged, or it is a dead condition will be there. So that has been sensed by this corresponding solar charge controller, and simultaneously whatever the power is coming from the module or the solar array, it has been diverted towards the battery bank system. And we can give direct connections to the DC loading system also. So whatever the home appliances that is running on the direct current basis, so whether it is a LED light, whether it is a tube light, whether it is a DC fan or DC television or any kind of a system, that we can directly connect to the charge controller and we can get the corresponding power to run these DC loads over here. Simultaneously, whenever in the night time, basically whenever the solar module power is not generated, solar charge controller sends this corresponding thing, and again it will going to extract the power from the battery bank system over here actually. And from the battery bank it will start powering the load which is running on the direct current basis over here. So that is why whatever the variable form of the voltage and the current we are getting, it has been converted to the stable form. Again, the battery will go into charge by controlling the voltage and the current for the battery with respect to the sensing the status of charging of the battery, and we can give the direct loading to these corresponding DC loads towards the charge controller over here. So basically in most of the cases for the smaller solar home systems for the residential scale or the rural area, basically such kind of a system is more recommended to having some kind of the DC load for their working purposes. Now in the second case actually, here we just going to talk if we are powering the AC load in the corresponding system, then how the role of the solar charge controller will be in the given systems over here actually. So basically whatever the solar power has been generated by the solar panel, it has been given to the solar charge controller. So in this case we have to decide actually what amount of the voltage, that is a rated voltage, is given to the charge controller, what amount of the sizing we have done for the solar charge controller, and what is the battery bank voltage we are using in the corresponding system. So basically either we can just use the PWM, that is a pulse width modulation charge controller, rather we can use the MPPT charge controller also. So basically the pulse width modulation is a spherical waveform has been generated by this corresponding charge controller, and basically when we are talking, it is a less efficient comparing to the MPPT charge controller. MPPT stands for the maximum power point control or maximum power point algorithm basically. So such kind of the softwareical algorithm has been fitted in the charge controller. So the MPPT tracker tracks the maximum amount of the voltage and the current that can be extracted from the given array of the solar systems over here actually. So in that cases, either we have a rated system voltage, rather we have the max amount of the voltage that we are feeding. So there are two cases basically. If we are using the pulse width modulation type of the charge controller, then we have to control how much amount of the voltage we can give it to the charge controller. Every solar panel will there having the rated voltage. Every solar panel will have the maximum power point voltage, the VOC voltage, and the rated voltage also for the corresponding cases. So according to that, either we can balance the voltage that we are feeding to the charge controller, or if we are using the MPPT charge controller, then that time we can just give the connection to the MPPT. MPPT charge controller over here convert this corresponding voltage into the system voltage or the battery bank voltage which is required to charge the battery in the corresponding capacities. So that is why nowadays the MPPT charge controller is been more preferred over the PWM or the pulse width modulation type of the charge controller. So either we can feed the higher voltage also comparing to this rated voltage what we are required for the running the battery bank. Automatically charge controller will lower down that corresponding voltage to the standard voltage what is required to charge the battery over here. Now further connection we can give towards the inverter. Inverter we are giving because we want to run the AC loads in the systems over here. So once the power of the DC has been inverted to the AC power, then we can give the connections to the AC home appliances over here. So whenever in the night time the sun power has not been available, solar charge controller senses that and it will just take out the power from the battery, or basically the inverter senses that it can take out the power from the battery and again try to invert the voltage, that is the DC, up to the AC form of the electricity. So in the AC load, when we are designing the system, the role of a charge controller is to convert the variable DC form to the stable DC form. Second thing is what, if we are giving the voltage more than the system voltage what is required for the battery bank system, so in that cases it will reduce the voltage up to the charging status of the battery. And if we require to connect some kind of the DC loads in the system, so that also we can directly connect to the charge controller. So these are the quite important functioning the charge controller is doing whenever we design any kind of the solar home system in the smaller capacity.